All right, guys, so 2.2 states limits involving infinity. So our first definition is the horizontal asymptote, which we already studied in Algebra 2. Let's start with the definition. If the limit as x approaches infinity, okay, of some function, let's call it f of x, equals to a b value, or if the limit as x approaches negative infinity of some function equals to b, then your horizontal asymptote, which I'm going to use HA, is y equals to b. Now, remember, the x value could approach either negative infinity or positive infinity. And if it comes up with a value, okay, then the horizontal asymptote is y equals that value. I am going to make a remark though, guys, okay? A function can have more than one HAs, okay? Or no HAs at all, or no HAs at all, okay? Because in Algebra 2, we study that a function could have multiple VAs, vertical asymptotes, but I do not remember teaching that a function could have more than one HA, so that's why I want you guys to be aware. So let's look at example 1. It says for the function f of x equals sine 2x over x, use graphs and tables to find. It is our very first example. That's why it is asking us to use graph and tables. For this particular case, I'm going to show you the graph first on Desmos, and then I'm going to talk to you guys through it, okay? Okay, so I've already typed in the function sine of 2x over x. Okay, so we want x to be approaching negative infinity. So what's happening is I'm going to go left here. As I'm going left, what's happening is this curve is getting closer and closer to the x-axis, right? So if I zoom all the way out, you can just tell like at negative 70, it looks, the red curve, it's sort of getting to be on top of the x-axis. So it's getting closer and closer to 0. On the right side, it's the same thing. If I'm going to 140, 150, as further out I go to the right towards infinity, the red curve, which is your function, it's pretty much on top or the same as the x-axis. So that means it's getting closer and closer to y equals to 0. Now, when we are closer to 0, that's really not the case here. If we were to say find the limit as x approaching 0, it appears that the height is at 2. But we're not interested in x approaching 0 at this time. We're interested in x approaching either positive or negative infinity. So from Desmos, right, we saw that either positive or negative infinity, they're both 0. Now, then it says, now identify all horizontal asymptote. Well, based on our definitions, guys, if the limit is approaching infinity and equals to a real number, similarly to as x approaches negative infinity and it equals to a real number. Remember, this is an or, so that means one or the other could happen. They both don't have to happen. Then that allows us to say, hey, yes, we do have a horizontal asymptote. In this particular case, it is at y equals to 0. Now for the function y equals 2x plus sine of x over x, find the limit of y as x approaches positive and negative infinity. So we'll break this up. First, we will go to find the positive one. Because we do have one denominator, we are going to break it up as 2 pieces, just like this. And that will allow us to break it up even further. Okay, so 2x over x is now 2, guys, plus limit as x approaches infinity of sine x over x, okay? So the first piece, the limit as x approaches infinity of 2, well, clearly that will always be 2, okay? Doesn't matter where x is at, the y value is 2. Now this piece right here, we're not going to use a graphing calculator or decimals. Let's kind of think about this. So we're looking for what y value it's going to give us as x is getting bigger and bigger to the right side. Well, guys, sine, the y value of sine can only be from -1 to 1, right? As x is getting bigger, like 20, 30, 40, 50, 60, in this case, infinity. Well, infinity to us could be 1,000,000, okay? Could be 10 million, could be however many zeros I want to write out. So doesn't matter what the denominator is. We just know the infinity is really, really big. But on the top, your numerator can only be from -1 to 1. So if you pick the extreme ones, like -1 divided by 1,000,000, it's getting really, really close to 0. And then if you pick 1, it's also going to get closer to 0. So the limit as x approaches infinity of sine of x over x will always going to be 0. Okay, so that will allow us to say, well, 2 plus 0 is 2. Well, that's a b value. That's a real number. So right now we do know that we have 1 HAs. Okay, let's do the left-hand infinity there. So limit as x approaches -infinity, I will go straight to this, okay, to x plus sine x, just like that. And we do know, we can break this up, limit as x approaches -infinity of 2, that will always be 2. And this concept is still the same thing, right? So we are going to have sine of x over x, guys. Well, same thing. So the range of this is going to be from -1 to 1. So if you pick -1 divided by something negative large, like -1,000,000, you're still going to get closer and closer to 0. Remember, it's a positive, negative, tiny, tiny number, but 0 doesn't have a positive, negative. So we are going to say this is also 0. So this is going to say 2 plus 0 equals 2. So they're both equaling out to 2. Now, if I said, hey, do we have any HAs? Yes, we have HAs then. HAs would just be y equals to 2. So now that we have a little bit more understanding about the infinity and -infinity, let's go back and talk about this one without a graphing calculator, okay? So if we're saying, okay, find the limit as x approaches either -infinity or positive infinity, it doesn't really matter. Let's talk about this really quickly. Okay, same concept, right? This 2 inside, guys, that's a horizontal compression. It does not change your y value, the range. So the numerator will still have a range from -1 to 1. On the bottom, you got x, right? X is just approaching -1,000,000. So -100,000, -1,000,000, negative whatever. However many zeros you want to add on. So the more zeros you add on, the closer to 0, the smaller answer you're going to get. So if you pick -1 divided by -100,000,000, you will get a positive tiny number. And then if you pick 1 divided by a negative number, you will get a negative tiny number, but it's getting closer to 0. So it doesn't matter. 0 doesn't have a positive or negative. So that's why earlier when we graphed these out, we had 0. Let's do the next one. Okay, we do have properties of limits as x approaches infinity, guys, but they are the same as the properties of limits we wrote down in 2.1. So I didn't want to write that again. Let's do example 3. The direction says, for the function y equals x times sine of x plus 2 times sine of x divided by 2x squared. Find the limit as x approaches positive and negative. So we are going to do, how about this? We'll split it up. X approaches positive here. And then we are going to write x times sine of x plus 2 times sine of x. Looks like we have a monomial on the denominator, so we're gonna definitely break it up. Okay, so first step, break up into now 2 fractions. So x approaches infinity, x times sine of x divided by 2x squared plus limit as x approaches infinity of 2 times sine of x all over 2x squared. Let's see if we can reduce. So limit as x approaches infinity. Okay, let's see. that x and one of those, I have that left. So we have sine of x all over 2x. So that's what we got over here. The 2 can go. Okay, so that's going to allow us to say limit as x approaches infinity of sine x over x squared. Now, if we really wanted to, guys, we can break this up even further, right? This is a 1 over 2 times sine of x over x, just like that. And then over here, we can break up the sine x here. So limit as x approaches infinity, sine x over x times 1 over x. Okay. Concept-wise, just make sure you're really understanding this. Okay. Now, since we have a constant, this constant can go out in the front. So this could be written as this. Limit as x approaches infinity of sine x over x. Okay. Let's look at this first, and then we'll look at the other one. So just like earlier, students, okay, sine x, okay, again, the range, the y value of that can only be from -1 to 1, divided by an infinity number, okay? So an infinity number meaning that it can, like, just pick 1,000 for the sake of simplicity. So if you have a -1 divided by 1,000, that's a negative tiny number close to 0. You pick +1 divided by 1,000, it's a positive tiny number close to 0, but 0 doesn't have positive and negative. So for this one, it's going to be 1/2 times 0. Similarly to over here, same exact concept, right? It's still going to be 0 here. So 0 times 1 over x, or I would say this, 0 times the limit as x approaches infinity of 1 over x. Well, it doesn't really matter what the limit 1 over x is. 0 times anything is 0. But let's just kind of go further. Well, 1 divided by 1,000,000 is still 0. So in reality, this is still going to say 0 times 0, like that. So this answer has come out to be 0. Now, this side, we are going to use x approaches -infinity. If it's okay with you guys, I'm just going to go straight to this breaking step here. Or actually, yeah, let's go straight there if that's okay with you guys. So, you know what? I'm going to even pull that constant out in the front. Limit as sine of x over x, okay, plus limit as x approaches -infinity, sine of x over x times limit as x approaches -infinity of 1 over x. Okay, remember this is -infinity, so let's pick -1,000. So if x is -1,000 in the denominator, and remember sine has the range from -1 to 1. So by now we know that, hey, it doesn't matter if you pick -1 or 1, it's gonna divide by some ginormous number that will be 0. Same thing with this. This case, we only have 1 divided by -1,000,000, -100,000,000. That's going to be very close to 0. So this side, student, is still going to be 0.